Hello students, today's class we will be learning about the remaining portion of the language of chemistry, that is from chapter 1 in ICSE class 9 syllabus. Today we have to begin now with relative atomic mass. There is a separate video for balancing chemical equations. That part I have tried to skip here, and I will be basically dealing now with relative atomic mass. Relative atomic mass. Basic idea you must be having that if there is an atom having neutrons and protons in the nucleus, and electrons are revolving around the nucleus. So there is an statement saying that the entire mass of an atom lies in the nucleus. In other words, we can see that the nucleons present, like protons and neutrons, so their mass will give us the clear idea about the atomic mass. We can see that the mass of nucleons, and nucleons means neutrons and protons. But there are problems. How will you measure the mass of an atom? Atom itself is very small, microscopic. So it was difficult to measure the atomic mass. And therefore, they tried to devise a way to define relative atomic mass. Initially, hydrogen was used to define atomic mass of atoms of any element. Here you will understand that in 1967, in 1961, I think it is 61, carbon 12, which is an isotope of carbon, was adopted as a standard weight or unit to determine the atomic mass of an atom of any element. See, you must have visited a market where you find a physical balance. They sell vegetables, they sell fruits or grocery items where this physical balance is used, and you must be having an idea that physical balance is actually used to determine the mass of an object. So what general thing we'll try to compare? You take, for example, let us say oxygen atom, this weighing pan we will take, And you all know that C12 has how many nucleons? It has 6. 1, 2, 3, 4, 5, 6. And we have 6 protons. Altogether, how many nucleons? 6 protons plus 6 neutrons we have. And you must be having an idea that the mass of a proton is equal to the mass of a proton, almost equal. Therefore, we will take out one nucleon. And one nucleon we can represent it as 1/12 of mass of C12. Mass of C12. Suppose there are 12 particles in the nucleus of an atom and you have removed one particle. So mathematical way, how can we call it? We can call it 1/12 times the mass of C12 atom. C12 atom has, let us say, 12 units in it. You have removed one of it, so it is 1/12 of the total mass of the C12 atom. So similarly, I tell you that I have removed here one. Now, if I wish to compare oxygen atom using this one, let us say this one is unknown quantity, but this is known to us. This is known standard weight. Suppose when you see in a vegetable market one weighing pan, we find unknown things, like let me say you have gone to buy apple. Other side you will find weight box is there. Using that they are trying to compare. Once it becomes equal, they give you suppose a kilo of apple. So weight box is used. Similarly here in chemistry, 1/12 times the mass of C12 is used as a unit to define how many times an unknown atom is heavier. For instance, I have taken here oxygen atom. So I may put here, and how many I may require? I may require 16 into this. 16 into this unit. This is the unit which I have taken. What does it mean now? What have we got it about oxygen atom? We get an idea that compared to carbon, means in relation to carbon, oxygen atom is 16 times heavier than 1/12 times the mass of an atom of C12. 16 times it is heavier. हिंदी में कहें तो एक ऑक्सीजन एटम कार्बन के 1/12 की तुलना में 16 गुना ज़्यादा भारी है। एक कार्बन एटम में 12 यूनिट्स हैं, वहाँ से एक यूनिट निकालिए तो उस यूनिट की तुलना में एक ऑक्सीजन एटम 16 टाइम्स 16 गुना ज़्यादा भारी है। तो इसलिए अगर कोई पूछे तो शॉर्ट में कहें कि 1U का मतलब क्या? 1U का मतलब है 1/12 टाइम्स मास ऑफ C12। तो इसलिए रिलेटिव एटॉमिक मास ऑफ ऑक्सीजन मीन्स 16U, या इसको AMU लिख सकते हैं, या फिर 16U। और यहाँ पर याद रखिएगा कि 1U मतलब मास ऑफ प्रोटॉन होता है 1.6605 इंटू 10⁻⁻24 ग्राम, जो कि मास ऑफ एक न्यूक्लियन और मास ऑफ अ प्रोटॉन और अ मास ऑफ अ न्यूट्रॉन you can call it. So here we have compared it, so this is how you define. So now we can write the statement stating the relative atomic mass. So relative atomic mass is equal to mass of an atom of an element by 1/12 times mass of C12 atom. So this is the formula we get. Suppose you are given somewhere that what do you mean by, what do you mean by relative atomic mass of calcium is 40U. What do you understand? It means that the mass of calcium is 40 times 1/12, 40 times compared to 1/12 times the mass of C12 atom. This is what we understand. So I hope it is clear to you how this idea of relative atomic mass came. Now for a short revision we can say the relative atomic mass means, relative term is used since it is a mass of an atom is always taken in reference, in relation to the mass of C12 atom, and that also 1/12 times the mass of C12 atom is considered as a unit to define the atomic mass of other elements. Using these basic concepts of relative atomic mass, you can get relative molecular mass also. Relative molecular mass. RMM. This topic is very simple. If you wish to calculate relative molecular mass of a molecule of a compound, you have to just add the relative atomic masses of all the atoms present in a molecule. For example, we can say it is the sum of all atoms It is the sum of relative atomic mass of all atoms present in a molecule. For example, relative molecular mass of CaCO3 means you have to calculate for calcium, you have to calculate for carbon and 3 atoms of oxygen. Calcium, it is 40 AMU, or simply write U. For carbon it is 12U, and for oxygen it is 16U. All together we will add 40U plus 12U plus 48U is equal to, we will get 100U. Okay. Sometimes you might have seen, this is the unit, or you might have heard that it is expressed in gram. Does it mean that in real sense that one oxygen atom weighs 16 gram? No, it is just expressed. So it is gram atomic mass, means relative atomic mass expressed in gram. For example, relative atomic mass of potassium is, let us say, 39U. So therefore gram atomic mass of calcium would be 39 gram. Similarly, gram molecular mass of calcium carbonate is, let us say, 100 AMU. Therefore, this is relative molecular mass is 100 AMU. Therefore, gram molecular mass of CaCO3 will be 100 gram. In practical sense, if you try to weigh, you may not get 100 gram. A molecule of calcium carbonate will never weigh 100 gram, but it is just used to express in terms of gram. This is what you have to remember. We have 2 more small topics which we will be discussing from this language of chemistry, chapter 1. One is percentage composition. Percentage composition. What is percentage? It is the relative mass of an element. It is the percentage is the relative mass of an element present in a molecule of a compound or only molecule. In terms of percentage, then it is called percentage composition. Relative mass, how much it is present. Let us take, for example, For example, as a question we will take, calculate the percentage of calcium in CaCO3. So solution, we have to calculate first relative molecular mass of CaCO3. You have just learnt 40 gram plus 12 gram plus 48 gram, you will get 100 gram. And relative molecular mass of calcium will be 40 gram. Here I have expressed in terms of gram, so need not to get confused. Therefore, percentage composition of calcium in CaCO3 is equal to relative atomic mass. We can say here relative atomic mass. So it will be relative atomic mass of calcium by relative molecular mass of CaCO3 into 100. It is 40 gram divided by 100 gram into 100. So we will get 40%. So this will be the answer about the percentage composition of calcium in a molecule. Similarly, you will be able to calculate the percentage of carbon present, percentage of oxygen present in it. So this is easy to calculate. Next topic we have, that is empirical formula. Empirical formula. Empirical formula is the simple whole number ratio. Simple whole number ratio of elements in a molecule. For example, you can understand. Let us take hydrogen peroxide. Molecular formula. It is H2O2. Then what should be empirical formula? It should be HO, because 2 and 2 will get cancelled, so the ratio would be HO. Similarly, you can take one more example to understand. Let us take second example. This one, consider it as first example. Here we will take glucose. So glucose molecular formula C6H12O6. Then empirical formula would be C, 6 1 is 6, 6 2 is 12, and okay, let me tell you, C6H12O6, 6 1 is 6, 6 2 is 12, 6 1 is 6. So we will have empirical formula as CH2O. So I hope you have got it, how to calculate the empirical formula of two compounds here. Here, my dear students, we come to the end of this chapter. We can say I have explained to you, making you understand language of chemistry. Not the entire thing I have told you, but whatever the topics has to be covered in this chapter, the language of chemistry, ICSE class 9, briefly I have tried taking some sample examples. For detail like radicals and all, you have to memorize the radicals along with their formal charges they carry, so that you may find easy and you will be able to write the chemical formula, and it will be very useful balancing the equations. So thank you for watching this video, and we will see in our next chapter of ICSE chemistry class 9. Thank you once again.